Hi guys, so I'm filming a video after a very long time, and just so that you know, I'm filming it for the second time, right? And I'm not taking any sympathy from you. I'm just telling you that yes, it takes some efforts to make a video, right? So basically, before this, when I tried to film, the file got corrupted. I tried to recover it for a couple of hours, but it did not work, and I don't know why it got corrupted. But anyway, so I wasted a couple of hours. Maybe in that time I could have made another video, um, but I could not, unfortunately. And but I believe that everything happens for our own good, and so maybe because I don't know, maybe it wasn't filmed right, or I could have filmed it better. But anyway, whatever happened, maybe it made me more tolerant or more patient, whatever it was, right? Since I'm making a video after a very long time, there are a few things that I want to discuss which are important. So it will be great if you could spare some time for that. And those of you who are very short on time, like I am right now, I am very short on time. So you can just go ahead and start watching the video from 6 minutes, where I've discussed questions from kinetics. So you can go ahead and skip this video to 6 minutes, but whatever I'm talking right now, that is also very relevant. So if you could just listen to me. So first of all, why I have not been regularly making videos? Well, the reason is that recently I have started learning a new software. Okay, it's a molecular docking software or molecular modeling, whatever you like to call it, where we take certain enzymatic targets and try and bind drugs, which basically identifying a molecule which could be an active drug target, right? So I'm currently doing that molecular modeling studies, and since it's a new software for me, I have done it before, but this one is a new software, so it takes me time to learn the software, to learn the set of skills that are required to operate that software. And along with that, I'm doing a workshop where I'm trying to from the XRD, single crystal XRD, whatever data we get, how to interpret the structure, and that requires a lot of mathematical calculations, and it's quite extensive calculations that are required, which are cumbersome as well. So together both these things are because of which I am not being able to make the videos, right? So this is the first reason. The second thing, or the second point that I want to discuss, is that now I'll be making videos, since I'm short on time, on both gate and net. Both gate and jam. And the reason is, many of you, like especially for physical chemistry, if I label the video gate, then the jam students don't watch, and if I label the video jam, then the gate students don't watch. But what I want to emphasize on the fact is that in the last 3-4 years, I mean, if you look at the papers in the last 3-4 years, the toughness or the questions from physical chemistry especially are equivalent. I mean, you cannot actually distinguish between the level of a gate and a jam question from physical chemistry. So it becomes very important to practice both the questions. And the problem is, I have been again and again telling to gate aspirants that you should practice jam questions, especially for physical chemistry, but I think none of you follow that. So I think it's better that I put on the questions from both gate and jam, and I do not tell you which question came from which paper, right? So that you can actually practice both. And trust me when I'm telling you, just trust me on this, that if you practice jam or if you practice gate, vis-a-vis, if you are a jam student and you're practicing gate questions, and if you are a gate student and you're practicing jam questions, from organic, inorganic, I can still say there's some difference. But over the past 3-4 years in physical chemistry, there's actually no difference at all in your toughness of jam and gate papers, right? The third thing that I want to tell you is that this is like I have a lot of questions. I have a huge questions. I have huge set of questions from all the subjects from physical chemistry. But I do not have a particular way of writing all those questions or solving all those questions. So if you can please come up with a suggestion on how I can do more questions without editing the video, because editing the video takes a lot of time, right? And if I try and edit the video, then again I'll be only uploading about 1 or 2 videos in a week. Whereas if I do not edit those videos, I have more time to make even more videos, and the frequency increases. Then I can actually make a video every day. So if you could please suggest me a way by which I can make more questions without editing, I'll be really glad. You can just comment down in the comment section and let me know whatever way is feasible. The fourth point that I want to make is, which is the most relevant. Many of you keep requesting me videos from physical chemistry, right? And I love physical chemistry, no doubt. But since my research is more oriented towards organic and inorganic, I do practice a lot. I mean, somehow it comes into the picture. So organic and inorganic are like the concepts of organic and inorganic are on my tips. So I just need to revise for about say 2 minutes or 5 minutes, and I can come up with a video on organic and inorganic topics. But physical chemistry I have not been practicing much. Yes, during the time when I had my during the time when I had my exam, I used to do physical chemistry questions, and at that point of time the concepts from physical chemistry were there on my tips. But now I have to come revise and then make a video, and that takes a hell lot of time, right? So if you want to see more and more physical chemistry videos, you would see a less frequency of videos from my side, because it requires time. And many of you are demanding quantum chemistry, and trust me, I can make quantum chemistry really simple for you, because yes, at that point of time it was very tough for me as well, but now I have understood it well and I can actually simplify it for you guys, quantum chemistry, right? But the problem is that it requires a hell lot of time to come up with a structured program or structured syllabus by which I can teach you, right? Physical chemistry topics I can teach you from the book, but I hate that, okay? I am not that kind of a person who would teach you from the books, because I strictly believe that teachers who teach you from the books, I don't know, I mean, it's my personal feeling that you cannot teach well if you are teaching from a book, okay? So I always prefer not to teach from books. I mean, obviously I go through the books, but not like I'm looking at the book and then teaching you. I hate that, okay? So I will never do that. And because I feel that if you are teaching directly from the book, you're not applying your own mind, you're not applying your own ideas, your concepts are not that clear. Because if you can actually explain something by reading the book and then explaining that thing in your own term, that is something that justifies that yes, you know the concept well. Otherwise I don't think so that it is actually good to teach from books, right? And yeah, so that's about it. And so let me just start, and you can just comment down whatever you want, whether you want more physical chemistry videos or not, so I can concentrate more on physical chemistry, or otherwise I'll keep on uploading say 1 or 2 videos from physical chemistry at least in a couple of weeks, 2 videos in 2 weeks, right? So basically a video each week I'll be uploading from physical chemistry. So for those of you who are preparing for 2019 exam, let's say GATE 2019 or JAM 2019, for them it will be very beneficial, because till then you will have a lot of content from physical chemistry as well by that time. But yes, for those of you who are preparing for this exam, this coming exam in 2018, for them, yes, I have very less content from physical chemistry, and like I told you, this is the very reason, nothing else. Not that I do not know physical chemistry or it's very tough, it's actually very simple, just that the concepts are not there on my tips. I'll be honest with you, right? You cannot actually try and have all the concepts from all the subjects on your tips. It's very difficult, right? So anyway, let's discuss some questions from Kinetics. And the thing that I'm going to do differently this time is I'll keep on going and checking every 4-5 minutes, so please do not mind that. You can say it's some kind of whatever you can say, some technical issue with my videos, so just bear with that, right? And like I said, I'll just check once, right? So about 9 minutes have passed, and I'll check after every question or after every couple of questions. So the first question is that the rate constant for a reaction is 1.25 into 10 to the power minus 4 mole per liter per second. Initial concentration is given to us as 0.250 mole per liter. The total time required for complete conversion. So what has been given to us, that there is some reactant A. The rate constant is given to us as 1.25 into 10 to the power minus 4 mole per liter second. It converts into B, okay? So they have asked how much time is required for this reaction for the total conversion of, A to B. In the question they have framed it differently. They have said the total time required for complete conversion, right? So the time in which this A completely converts to B. They have not given what is the order of the reaction. So sometimes when they are not giving the order of the reaction, you can find the order of the reaction from the rate constant. So for this particular rate constant, mole per liter per second, it's a zero order reaction. Okay. Similarly, if it's a first order reaction, the units are second inverse, and for a second order reaction, the rates are whatever the rates may be. So you should know the rate for a zero order reaction, for a first order and a second order, because generally these are the ones which are asked. If you look at the last 5-6 year papers, I mean, nothing out of these three have been asked. Either they ask zero order, first order, or second order. So you should know the units of these three order reactions, right? Now this is a zero order reaction that we figured out from the units. So from the units we figured out it's a zero order reaction, and the formula for a zero order reaction is Kt is equal to A naught minus At, where this A naught is the initial concentration, and the initial concentration is given to us as 0.250 mole per liter. This is given to us, the initial concentration, right? The initial concentration is given to us. The answer, they are asking the total time required in seconds. They are asking the total time required in seconds. Now what is this AT? AT is the concentration of A at time t. Okay, what are they asking? Complete conversion of A to B. At what time does the complete conversion of A to B takes place? And it is given to us that this AT is actually the concentration at time t. Now we want this AT to be 0. We want the time at which it completely converts to B. That means the concentration of A we want at that particular time at which the concentration of A is 0. That is, all of A is converted to B. That means this AT should be equal to 0. We want the time at which the concentration of A is 0. That is complete conversion of A to B. So this term becomes 0, and K is given to us as 1.25 into 10 to the power minus 4 mole per liter second, which is equal to into time. Okay, K, this is the value of K into time is equal to initial concentration. Initial concentration is given to us as 0.25 mole per liter. So if you solve this, your time comes out to be, time is equal to this will come out to be in seconds. So it comes out to be, if you calculate, 2000 seconds. How? Basically just divide 0.250 by 1.25 into 10 to the power minus 4, you will get 2000 seconds. Mole per liter will cancel out, and you will get seconds on the numerator. So you will get time equal to 2000 seconds, right? Another simple way, it's a little risky way, but a simple way to solve it is, if you do not know any formula, you see that the total time required is in seconds, and you have been given the units. So what you do is, you divide the units so that you get the answer in seconds. So this has been given as mole per liter per second, and this has been given mole per liter. Okay. Alright, so someone somewhere is trying to stop this video from completion, because just now the lights went out and I don't know what's happening, but it's better to laugh it out than to crib about it. So anyway, I'll try, and hopefully this video I can complete and upload today. Otherwise I'll be uploading tomorrow. Yeah, anyway, so I think you got this method. What I was telling you was that if you divide the units and somehow get the units in terms of the answer, so the answer is asked in seconds, and whatever values are given to you, if you divide those values, those units somehow, and get the answer in seconds, then most of the times it does help you out. So in case you are well behind the cutoff, let's say the cutoff for gate is around 30 and you're getting around 26, 25, then it's better to take the risk and do those questions. You might as well get some answer, because if you're getting a numerical type question, there's no negative, so you can just try it out. I mean, there's no loss in answering the question, because you won't be getting a negative for numerical type questions. Numerical type, I mean, where you do not have an option, you just have to write the answer. Okay. Anyway, so let's move on to the second question. And the second question says that this question is a typical gate question, because the gate questions are quite simple. Either they'll try and twist your mind by giving you, the question is very easy, you find out the answer, but they'll ask you the answer in some other units. So until and unless you do not know the unit conversion, you will not be able to solve that question. And these type of questions are typically asked in your GATE exam, or they will twist the question in a certain way. It will be a very easy question, but they will twist in a very small way, by which the student gets confused. So the question is that the rate constant depends on temperature by the following equation, and the equation is that your ln k is equal to minus 5000 upon t, okay, plus 10. This is your equation, minus 5000 by t plus 10. So your rate constant, or ln k, your rate constant depends on temperature by this equation, right? So they have asked what is the activation energy. So they have given just this particular equation and they have asked you the activation energy. Now all of you know that there is a general formula, ln k equal to minus Ea by RT plus ln A. This is a general formula that you all come across in your kinetics, whether it is for JAM or for GATE, or at master's level or bachelor's level. So if you see, the coefficient over here is t and the coefficient over here as well is t. So basically this ln A is equivalent to your 10, and you can equate this minus 5000 by t equal to Ea by RT, minus Ea by RT, because both of them have temperature as a coefficient. Both of them have temperature as a coefficient. So if you analyze these two equations, or if you equate these two equations, then from this equation you can say that minus 5000 by t, okay, is equal to Ea by RT. Since the coefficients are same, we are equating both the equations. So minus 5000 by t is equal to minus Ea by RT, is equal to minus Ea by RT. So minus minus gets cancelled, t gets cancelled. So basically all you are left with is Ea by R is equal to 5000. Now the answer they have asked is in kilojoules per mole. I have not written down over here, but the answer they have asked that find activation energy in kilojoules per mole. So what you need to do is your R value, you should know the different values of R in terms of units. So R is equal to 8.314 joule per mole. R is equal to 8.314 joule per mole. Okay, this is the value of R in joules per mole. So what you need to do now is you just have to, now the value of R you know, the value of R you know, so you have to find the value of Ea, that is your activation energy. So I just told you that R is equal to 8.314. So you multiply 5000 by 8.314, and what you get is, if you multiply 5000 by 8.314, you get somewhere around 43,000 joule per mole, right? But you need the answer in kilojoule per mole. So be careful. Now you have to convert this into kilojoule per mole. So this comes out to be 43 kilojoule per mole. This is the approximate answer. In the exam you will be given a calculator, so you can find out the answer from the calculator. But the approximate answer will come out to be 43 kilojoule per mole, right? So this was a very simple question, but a little tricky one, right? Now the third question is T half for a zero order reaction depends on the initial concentration as C naught means your initial concentration. So the T half, that is the half life, or the T half, I guess all of you know what is a T half, right? So T half for a zero order reaction depends on C naught as, okay? So they are asking how does it depend on the initial concentration, how does the T half depend on the initial concentration for a zero order reaction? That is what the question is suggesting. So I'll tell you a general formula with which you can find out for any order reaction. Here they have mentioned zero order reaction, but the general formula is that T half is inversely proportional to 1 by C naught n minus 1. This is your general formula for any order reaction, where this n represents the order of the reaction. N represents the order of reaction. So T half is proportional to 1 upon C naught n minus 1, where your T half, where n is the order of the reaction. So they are asking the relation between T half and initial concentration for zero order reaction. So for a zero order reaction, n is equal to 0. So T half is proportional to 1 upon C naught 0 minus 1 becomes minus 1. So 1 upon C naught raised to the power minus 1. Similarly, for a second order reaction, it will be 1 upon C naught, order of a reaction is 2. For a second order reaction, N is 2. So for T half for a second order reaction is inversely proportional to 1 upon C naught. And for a first order reaction, N is equal to 1, so 1 minus 1 becomes 0. So that means your T half is independent of the initial concentration. That is why for a first order reaction, if you see, the formula is T half is equal to 0.693 upon K, where K is the rate constant. So you can see that T half for a first order reaction does not depend on the initial concentration, it only depends on your rate constant. So this is the general formula that you can use to find out the relation between initial concentration and T half for any order reaction. So if it is a third order reaction, 3 minus 1, it becomes square. So T half is inversely proportional to square of C naught for third order reaction. Similarly, you can find out for nth order reaction. This is the formula for nth order reaction, right? Right. So now we'll discuss our last question, and that is, I have many more questions like I said, so if you could suggest me a better way or a method by which I can, ask more questions, or if it's okay with you, I can just read out the questions and then try and solve it. If it's okay with you, I can do that as well. So whatever you like, you just comment down, and according to your comments, I'll make the next video accordingly, right? So the next question is that the rate constants for a reaction at 300 Kelvin and 350 Kelvin are 8 and 160 mole per liter per second inverse. The activation energy for the reaction in kilojoule per mole, again you have to find out the activation energy, and for finding the activation energy, again a very typical general formula is your log K2 by K1 equal to minus EA upon 2.303 R 1 by T2 minus 1 by T1. This is a very general formula that you will come across in any textbook, right? So you need know, let's say this is your K2 and this is your K1. Similarly, 350 is your T2 and 300 Kelvin is your T1. So if you solve this, and so log of K2 is 160 upon 8, that is your K1, is equal to minus EA upon 2.303 into R. Now we have to find the answer in kilojoule per mole, but your R value we can find out in joule per mole and then convert to kilojoule per mole. So for R in joule per mole, it is 8.314 into 1 upon T2 is 350 minus 1 upon 300, right? So if you solve this, this comes out to be log 20, and log 20 is approximately equal to 1.30. So 1.30 is equal to minus EA. This value comes out to be approximately 19. 2.303 into 8.314 is equal to, this becomes minus 50 upon 350 into 300, that is your 1,05,000. So 1,05,000. So you can cancel out 0 and 0. So your EA is equal to, minus into minus becomes plus. So your EA, activation energy, is equal to 1.3 into 19 into 10,500 upon 5. Okay. So if you solve this, you will get the answer in joule per mole, and then you need to convert it into kilojoule per mole. So the answer comes out to be approximately 42 kilojoule per mole, if I am not wrong. Right? It comes out to be, it comes out to be approximately 42 kilojoule per mole. So this is the answer. So these are, you can see the questions are directly based on the formulas. There is a small twist in some of the questions, but mostly or generally the questions are directly based on the formulas. So if you revise the formulas well and practice enough numericals, you will be able to score a good, you will be able to score well in your GATE or JAM exam. So I hope you like this video, because I have actually put in a lot of effort, and please like, subscribe and share, and please do comment below, because I do read all the comments, I reply to all the comments, and whatever you suggest I'll do accordingly, right? So thank you so much and all the best.